In this section, we're going to talk about common denominator. So a key here to add is to make that common denominator. And you really need to see these denominators in factored forms before you can make a decision about what that common denominator is. So I'm going to look at example 3a. And the first thing I'm going to do is I'm going to break up the denominators into their factors. And so now I have to decide what would be the best denominator to add them together. Now, a comparison here, if you guys thought about, and I'll erase this in a minute, but numbers, let's say this was 1/6 and it had been broken down to 3 and 2, and you were adding that with 1/4, and you're thinking about 4 as 2 and 2. It's kind of what we've done right here. When you find the LCD of these, you don't maybe have to do as much work because you guys are a little more familiar with the numerical values, but basically you need a factor of 3 and a factor of 2. One of these has already been covered by the fact you have a factor of 2, but you need 2 factors of 2. So your common denominator here would be 12. We want to do the same thing with the polynomial. So when I look at the first fraction, it would need a factor of x plus 3 as well as a factor of x plus 2 for the denominator. The second fraction in our addition problem has x plus 2, which we've already covered, but another x plus 2. We don't have 2 of them, so I would want another factor of x plus 2. That means I can make this the denominator of both of those fractions and then add them together. So I'm going to multiply the first fraction by x plus 2 in the numerator as well as the denominator, because that's the factor it's missing to create this common denominator. In the second fraction, it's missing a factor of x plus 3 to create that common denominator, so I'll multiply in the numerator and denominator of that fraction. Now we can do that because it's like we're just multiplying a fraction by 1 because the numerator and denominator match. Now what we have is x times x plus 2 plus 2 times x plus 3. That's just looking here. Those are what need to actually go through the process of addition, and those are now over a common denominator that contains a factor of x plus 3 and 2 factors of x plus 2. Now you need to actually go through the addition process. You haven't done that yet. You've written the addition problem, but you actually haven't added anything together here. And you need to turn those factors into their own individual terms to see if there are like terms to add together. So by that, I mean you need to distribute this and see what do we have as individual terms here. We have x squared plus 2x plus 2x plus 6. And now I'm going to simplify that numerator. I'm going to continue my work right here. These two x's can combine together to make x squared plus 4x plus 6. Again, all the addition's happening in the numerator once we have this common denominator. And then I need to ask myself, the way that I have the numerator written as one factor with 3 different terms in it, can that numerator be factored into multiple factors? And it does look like a quadratic, but if you try to factor it, you'd be looking for things that multiply to make 6 and add to make 4. And that just doesn't happen, meaning this can't be factored, so it's like one big factor. And you don't need those parentheses around it. I'm just trying to emphasize to you guys that idea of factor like we have been throughout these lessons so that you know what you are doing and you aren't just crossing things out or canceling things that can't be. So now we can only cancel common factors from the numerator and denominator. The denominator doesn't have any factor that looks like this. And I know that if I multiply them together, they still won't make that because that can't be broken down. So that is my final answer. So my final answer when these are added together is x squared plus 4x plus 6 over this denominator. You do not need to multiply it out. Probably in this unit, most of the time we'll prefer things in their factored forms. All right, so I'm going to look at the second problem now, part B. When I go to think about the least common denominator, here I don't need to factor the denominators. This one already only has one factor, and it's a factor of x minus 1. The second denominator does not have that same factor. It has a completely different factor, so my common denominator will have to include both of those factors. To obtain that common denominator in the first fraction, I'll need to multiply by x plus 1 in the numerator and in the denominator. And in the second fraction, I'll have to multiply by x minus 1 in the numerator as well as the denominator. So now what I've found out is that the common denominator that they now both have is x plus 1 and x minus 1. In the numerator, the first numerator is this giant multiplication problem. X plus 1 times x plus 2. You guys don't have to write out as many steps as I do, but we saw in the last unit that some of you really struggle with multiplying out factors, and so I am going to keep it like this. There's a minus sign between them, so I'm going to write that minus sign, and then these two things are multiplying each other. Now, in order to simplify this, I still need to follow order of operations. I need to multiply before I subtract. That means I'm going to multiply these two factors together and get one quantity minus what I get when these two are multiplied together. And all of that will still be over this common denominator of x plus 1 times x minus 1. Now, I'm going to go off to the side to remind you guys of multiplication because a lot of you have been struggling with this. You cannot just multiply the beginnings and the ends together. You need to distribute to every term. Okay, so you need to make sure you understand exactly what those things are when they are multiplied together. So this first multiplication problem is going to give us x squared plus 3x plus 2. And if you do the same thing with x minus 3 times x minus 1, and pause this and go do that off to the side of your paper if necessary to make sure you can do it, you should get x squared minus 4x plus 3. Now that minus sign is subtraction. Remember that subtraction is distributed to each of these terms, so I can change it to an addition sign if I make sure that I've distributed it to each term. And so that will give me x squared plus negative x squared, which will cancel each other out. 3x plus 4x, which will now be 7x. And 2 minus 3, which will be negative 1. And I still have that common denominator. Now 7x minus 1 can't be factored any further, so again, we wouldn't write this, but I want to help your brain understand how to think about it. The 7x minus 1 is one factor. Notice that none of those factors are the same as 7x minus 1, so this is our final answer, that the numerator is the factor of 7x minus 1, and the denominator contains two factors, x plus 1 and x minus 1. All right. So I'm going to go ahead and work on this third problem. Again, starting with the denominator. So you should factor this first one with whatever methods you know. So pause it again if you have to see if you can get this, but I get 2a minus 1 and 2a minus 1. Now you guys need to be careful. That is not the same as 1 minus 2a. So 1 minus 2a, if you want to write it in the other order, it's the 2a that's negative and the 1 that's positive. And so it's like negative 1 times 2a minus 1, okay? So we're going to think about this as negative 1 times 2a minus 1. And because negative 1 is a number and we know how to deal with it, we can actually don't have to keep it in the denominator as long as we apply it to the numerator. Because multiplying by negative 1 is the same thing as dividing by negative 1. So I'm going to do that for right now. And now I'm going to determine what would the least common denominator be. So in the first fraction, I need two factors of 2a minus 1, and I'm going to write it in its more condensed form now that we've talked about it a little bit. So this is two factors of 2a minus 1. The second fraction has one factor of 2a minus 1. We've already covered that plus extra, so there's no additional factors I need to put in here, which means this first denominator is the common denominator. This second one needs to be multiplied by another factor of 2a minus 1. So the common denominator are these two factors of 2a minus 1. The numerator is the number 1 being added with this entire multiplication problem. Now, this multiplication problem, I would start with multiplying these two binomials together. So 1 times 2a, 1 times negative 1. Negative a times 2a, and negative a times negative 1. And I'm going to write them in standard form, that order that we're used to seeing. So it would be negative 2a squared plus 3a minus 1. Okay. Now, what I haven't done is multiplied all of that by negative 1. So now I want to multiply by negative 1, which would give me positive 2a squared minus 3a plus 1. So this is really like having 1 plus 2a squared minus 3a plus 1. And that's still over that common denominator. Now, the 1 and the 1 are like terms and can combine together. So I'm going to continue it right over here. I'm going to have 2a squared minus 3a plus 2, and that's all over 2a minus 1 squared. And then I would want to see if I can factor this numerator, okay? And then for those of you who like to use the x, that means you're looking for something that multiplies to make positive 4, but adds up to make negative 3. It seems close, but really to make a positive 4, 4 and 1 could make negative 3 if one of them was negative, but then they wouldn't make a positive 4. And 2 and 2 won't work to make the 3 in the middle. So this is not factorable. So this is going to be our final answer. So the other thing we're going to look at before addition is putting this addition idea together with what we talked about last time, which is complex fractions. So notice these are complex fractions, but they also have addition problems in them. So the first thing I really want you to do is I want you to think about these horizontally like we were before to understand what's actually happening here. Now, order of operations, you need to simplify the parentheses before you can do division. So don't take the reciprocal of this. What does that even look like? We don't know till we make it one fraction. So you really need to work on each of these individually before you can divide them. So first I need to do this addition problem. And the LCD for these would be 3, and this first fraction would be missing the multiple of 3, so I'll multiply everything by 3. And so I would get 3x plus x over 3, which simplifies to be 4x over 3. I'm going to do the other one in another color just to try and keep my notes a little organized for you guys. This one is missing a common factor of 6, so I'm multiplying top and bottom by 6. And this would say 6x minus x over 6, which is 5x over 6. Now I can go back to doing the division problem now that I have one fraction divided by another fraction. So this is 4x over 3 times the reciprocal of 5x over 6, which looks like this. And then there are some common factors that we can cancel out here. Here's a 1 factor of x in the denominator and 1 factor of x in the numerator, a factor of 3 in the numerator, and a factor of 3 in the denominator, leaving us with 8 over 5. I'm going to go through and do the same thing for example 4b. So again, first I'm going to write it out horizontally. I have this addition problem in the numerator, which is being divided by this fraction in the denominator. So I don't have to do any addition with that fraction that was in the denominator. It's already been combined together. So my focus first is just going to be to combine this one so I can work on the division problem rather than an addition problem. So the LCD for these, one denominator has a factor of x plus 2, the other a factor of x minus 5. So that will be the common denominator. So the first fraction needs to get multiplied by a factor of x minus 5. The second fraction will need to get multiplied by a factor of x plus 2. So let's think about what we have here. I'm really going to write this out so we can see the steps. We found our common denominator, and then in the numerator we have 1 times x minus 5 plus 1 times x plus 2. Remember, you need to multiply before you can add like terms together. So this would be x minus 5 when we distribute the 1 plus x plus 2. Be very careful here not to cancel these out. Your eyes might be telling you they can cancel, but these written in the numerator are not factors. They are being added together. Look at that. Those are not factors. Factors multiply each other. So I need to finish adding in the numerator. So I get 2x minus 3 when I combine like terms. And that 2x minus 3 can't be factored at all. So 2x minus 3 is the numerator in its factored form, and that doesn't match with anything in the denominator. So that is the finished addition problem. And now I want to divide that by this other fraction so I can actually do the division problem. So dividing by that fraction means I'm going to change this into a multiplication problem. So I have 2x minus 3, x plus 2, and x minus 5. I can change this to multiplication and use the reciprocal of the fraction I was dividing by. Now, I need to factor these. So again, how would you factor these? You're going to have to use whichever method that you're most comfortable with. And we should get these factors. So now, common factors in numerator and denominator. So 2x minus 3 has a factor in the numerator and denominator, x minus 5 has a factor in numerator and denominator, and x plus 2 has a factor in the numerator and denominator. And that just leaves me with 1 in the numerator, since everything canceled out but that, and then over x plus 1.